here. Okay, so what am I doing today? The main thing, the main goal is we are trying to get the obstacle collision logic working for today, which involves, you know, when we run into an obstacle, actually getting hit and falling down and getting back up or potentially dying. So the first part of that, we got to add collision boxes to our obstacles. I'm going to mark that not done because I was just setting up tests. And then we're going to need to figure out how to trigger both the falling down damaged animation as well as whatever collision damage logic there may be. So if that's applying a damage value, if that's some other logical state, tracking whatever that state is. And then these are more or less test cases for this. Yeah. Those are pretty much test cases for what I'm going to be implementing. So being hit by obstacles you're supposed to jump over, being hit by obstacles you're supposed to slide under, and getting hit by obstacles that just straight up block the lane and you should not be able to bypass. Yeah. We are adding a, let's just call it player collider so I can identify it. We will tag this as the player. Layer, avatar, sure, it doesn't really matter. For right now, let's add the capsule collider. Let's bring this radius in. We're gonna rotate it. Nope, sorry. Nope, sorry. There we go. Apparently I don't know my Z's from my X's. All right, so we got that going, and it looks like it's pretty well aligned with the torso there, if you can see that. Let's make this fairly tight for now until that feels like the wrong thing, and then make that pretty big so nothing can pass under her while she's running. That should be pretty good. Maybe we can make this a little fatter. I don't want it to be super tight. It's not really that much of a, it's not really a finesse free control game, at least not yet, not right now. It's more, it should be fairly clear when you've missed the jump or missed the slide. But we may need to be a little tighter than that to slide under things. So let's try there. And then maybe just slightly shorter and bring that down so it's not so much extending past the head there. Okay, let's go with that for now, and we'll see how that ends up. Okay, so we've got our new collider. I have a feeling, so I'm not really using physics for basically anything. We're not simulating physics for platforming. We're not simulating physics for much of anything right now. So I'm pretty sure I'm gonna want this collider to be a trigger. So, like I was saying, there's no real physics simulation going on these. So I don't need, I'm pretty sure I'm just gonna need a logical trigger for all this. Player obstacle trigger. So yeah, I already created a class to start hooking up listening for collisions. Let's see here. So this is a player obstacle trigger. We'll leave that name for now. I don't think that name is gonna stick, but a lot of this is not gonna stick, period, so. Let's get to prototype. Okay, so when the player's collider hits this, we want this logic to be different. So we're not tagging anything. We are just detecting when we have collided with something that is an obstacle. So let's see what I've named my tag. I'm pretty sure I just named the tag obstacle, but I have tagged the obstacles with obstacle. Look at that. So we'll call this the obstacle tag. Alright. If the other dot tag equals the obstacle tag, then we notify the prototype singleton of an obstacle collision. All right, so we have whenever this trigger collider detects that we've collided with another collider that is tagged obstacle, we tell the prototype singleton that that's happened and to do whatever it needs to do accordingly. So let's figure that out. And then I don't know if we actually need a trigger exit block for this behavior yet, but we'll just leave it blocked out. Just want to set up a public event for this new obstacle event that we're adding. All right, so what we want to do is public. What are we gonna call this? Obstacle collision. Flag obstacle collision. Because there may be, we don't want to call it something explicit like execute obstacle collision, or this is really a notification. We want to notify the singleton of the obstacle collision because we may be in a logical state that we don't want to do anything about it. You know, if we're in like a Mega Man just got hit by something and he's doing the little flashy bit where he's invincible, which I could very much see being the case in something like this. You know, if you've just fallen off a ledge or you've just gotten hit by a bullet, having a short invincibility grace period is probably something that might be necessary. So we have an obstacle collision, and then what do we need to do? We need to receive probably what it is that we have collided with, more than likely. So let's go with that. For now, it may not even matter, honestly. But since we have it, let's send it. Let's just receive. Well, for now, since we're kind of naively assuming we're gonna need it, let's just pass on what we're getting. Okay. Boom. So what we're doing is we have our prototype singleton instance. We tell it that we want to notify of a obstacle collision and pass it what we've collided with. So bang, that happens. Let's add a debug here because I am sure we're going to need to debug this to a certain degree. Notify obstacle collision. Sure. We'll just print the name of whatever that is. Okay, so that app to do is done. We have added the method, And now let's block out some pseudocode logic that we will follow up on implementing soon here. All right, so what are we going to do with this information? We want to see, get the player, check the player's state. For obstacle collision validity, we want to validate that we are in a state that can receive an obstacle collision. If it's valid, then we want to execute the animation and motion. Let's just call it execute the event actions associated for collision. We'll call it damage event, actually, for damage event. Okay. And then after damage event, do some kind of reset or check for game over state. So we'll call that a lost state check. A stub method for notifying the game state about an obstacle collision. That's good. So we have stubbed out the notify obstacle collision method, and now before I dive into that, what I really want to do is start working in some information about speed and how fast we should be going, because something that should happen when you trip and fall is you lose forward momentum. If you fall when you're running, you stop going so fast. So that is what we are going to do. Let's add properties for how fast you should be going when an event happens. So let's set speed default to, let me see what our current speed default is. Because I want to hook all this up at the same time and see if we can get some actually proper looking animations and speed timings going here. All right, so it looks like the current default for speed is 10. That's our average running speed right now, or what I currently have the animation controller tuned for, is running at a speed of 10. I think it's 10 units per second, 10 Unity units per second. So now that we have that, set a default to 10, and then if we go over here, that just compiled, we can look at our, let's just minimize things we're not looking at. We can see that we have a new speed. I also added a tween duration property to be used so I can start tuning. The wall run end was looking a little wonky, and I'm sure the wall run start could use some tuning. So I added a tween duration property, so that is dynamically set now. If we look at the internal logic for executing an event action, what used to be hard-coded to 1 second now is fed by the camera tween. Camera? Why is it using the camera? Nope, that is wrong. It should use the player motion tween duration of the event config data. So now that is what's going on. And then we'll similarly put in some new logic to tween the speed as well. And then I think we'll use the same tween duration to tween the speed, because I believe the timing should pretty much line up. So what I'm thinking about is that some events have a speed and some events don't, and how to reconcile that. Really what I want is less a speed and I think more of a modifier, because we're running it, the plan for the gameplay is not to have speed be a constant thing. It's something that can shift up and shift down based on certain parameters. So the idea, and I haven't really talked about this on stream, what the plan for the game design is, but the plan is dodging and avoiding each obstacle that the player avoids or dodges fills up a attack meter. If you think of like not Zelda, if you think of Secret of Mana, that had the kind of 100% charge attack mechanic, so it would charge up to 100 and it would hold there until you attacked, which would drain the meter, and then you'd have to wait for it to fill back up again to get the strongest attack possible. And that was their method of doing real-time combat in an action RPG that wasn't spammable. You couldn't spam the strongest attack nonstop. So kind of a related concept to what I'm about to describe, but what I'm planning on doing is having a meter. So if you just imagine that same 0% to 100% meter of attack charge or like energy charge, and every obstacle that the player avoids and successfully dodges, so that may be successfully jumping over an obstacle, successfully sliding under an obstacle, successfully wall running, whatever else they may be. So successfully getting past an obstacle will charge the meter some percent, and the higher your percent, at some point you'll flip over to a higher speed. Right now I'm just kind of imagining that as being 50%, and the higher your percent, the stronger your attack will be once there's enemies to actually attack and fend off. So yeah, it's kind of a loosely trying to encourage speedrunning actually feeling kind of interesting, for generally games that are kind of on rails, like this is a runner that is essentially on rails. It's not like Mirror's Edge or another, I'm trying to think of another game, I don't know, Assassin's Creed, whatever, but another parkour exploration. It's not a free exploration game, so speedrunning with a Rails game tends to be a little, the options aren't super interesting, right? And the idea here is that there is a level of management and difficulty. There's also a consequence to failing an obstacle. If you fail to dodge an obstacle, fail to navigate the enemies and the obstacles at the same time, taking damage reduces your charge, and you could drop below the sprinting percentage, which is, let's just imagine that's 50%. So let's say you start at the normal average run pace, and then you've dodged seven hurdles or slid under 7 to 10 things. I'm just throwing out random numbers, but let's say in the beginning of a level, you've dodged a bunch of stuff, and now your charge is, at 55, 60%, and once you've surpassed that 50% threshold, now you started sprinting. Your pace goes up, the level is going by faster, which means that obstacles and timing the obstacles has both changed and become a more rapid event. Like, the events are coming faster, which I imagine will mean that they are, by definition, more difficult to avoid consistently. So basically playing with the idea of dynamic difficulty and a game that's on the rails actually being interesting for multiple runs. Because a lot of, Rails games can have a tendency to, at least traditional ones, with set level design, replayability kind of is not super strong once you've beaten it once, because it's static, it's linear. So that's kind of what the design hypothesis is, and what I'm kind of looking at. Xena's paying attention for whatever reason, probably because we gave her a treat. All right, so that's kind of the reason behind what I'm thinking right now. So let's change this to a speed modifier instead. And then let's add that to the list today, because I think we can do this fairly easily. Task for today, add speed state. Add speed, traversal speed to game state. That's what all that rambling design talk was, is just describing that we are going to add traversal speed to the game state and events. So what we're doing now is, so now this is a speed modifier, and then let's just say, actually this default should change. Speed modifier, if it's a modifier, the default should definitely be 1 to not modify. So let's change that and then have that compile. Come on. There you go. Oh, balls. Fine. Oh, okay. To avoid manual entry, I'm just gonna remove the property and then re-add the property, because what happened is that it added the property to the component on my game object and stored the original default of 10. So let's just comment it out, let it recompile, and then re-add it with the default of 1, and then let it recompile again. And that's my ghetto hack for resetting the defaults on that to a 1.0. So that little hack worked, and all of my speed modifiers are now 0, or are now 1. So by default, events will just not adjust the speed modifier at all. And then what else we need here is prototype singleton. And then let's dive into the code scene a little bit, because I'm just basically doing all code right now, so we'll do that. And then I promise if Xena does anything interesting, I will pop her back up on stream with haste. Okay, so what we really want here is a song that is not gonna put us all to sleep is what we want. There we go. That's a better Monday vibe. Okay, so what we want is to add some speed properties for level design. For right now, let's just do this in a real stupid. No, let's not do it in a stupid way. Let's do it in a halfway legitimate way. All right, let's create a new script. A new script call, let's just call this level data. Reload my Visual Studio. And then come back to the code scene. And now let's make this just a data, my own data encapsulation for what? No, actually it should just be public. Oh! I hope you all enjoyed that that sound bite. If you can tell me what it is, I'll be super happy. All right. Xena's costume for the day has been picked, and it is Baby Yoda. Good girl. All right, she'll settle down eventually. What do you guys think? She's fine. She's actually pretty fine with it. We'll give her an extra treat for embarrassment reasons. Good girl. All right, Xena's all strapped up, ready to go. Let's get back to what we were doing. We'll bring down the zoom on Xena there. And then get back to what we were doing. So what I'm doing is I'm creating some creating a quick component that I can throw in our scene to control the parameters of speed. So we'll just this is probably going to be kind of a living, breathing prototype data type. So we'll just start adding properties as we need them for now until it's time to evolve into more proper code. But for now, we're just trying to move fast and have things that are easily tunable on the fly from one run to another. So we have we want to call this the sure, we'll just call it walk speed. And we'll have a average run speed. Or actually, let's throw it around the other way. Medium? Average? Average. That's fine. That's what we currently use. And then we'll do a run speed fast. I don't know what that exactly is going to be. And then we'll do a run speed sprint, possibly. That's like double speed. And then we'll do... What else is there? No, I think that's good. And then whatever speed we are at the moment that certain events happen, the event speed modifier can then adjust accordingly from there. What we're gonna do is we're gonna add that level data to our level. Fairly self-explanatory. Oh, right. What I want to do actually is put that on the prototype singleton. I want to have an instance of that for now. So we will do that here. All right. Let that compile, and now we will have a level data property to play with in the scene. Well, I had assumed so anyway. Oh, right. That's what we're missing. Yes, please import. In fact, I can probably dump those. And then do that is what I need. Let that compile. All right, there we go. So we have our level data now with our walk speed and our run average speed, and then potentially fast speed and sprint speed. So those are kind of already hooked up, and we can take a look at those here. I'll bring that over. So if you see here, we have this dash that can then become this. So you can see that's significantly faster. This is our current run. And then we can transition. You can see run and then duck your head down, and now we are in a boost. And then eventually, if I need to, I can create a middle. If I really want 3 speeds instead of 2 speeds, I just will probably pick one of these 2 animations and tune the speed of the animation itself. I'm pretty sure this one could probably take a speed up. I don't think this one could be sped up very much. That's already pretty damn anime run speed. So, but for now, the animation controller is set up for 2 speeds. And if you look at the logic for it here, we already have an attack power value. parameter in our animation controller, so we can set this attack power. And what this is listening for is while we're in this running state, the regular run that you've been seeing this whole time, if we detect that the attack power is exceeded 50, then we transition to the boost animation. So that's all hooked up in the animation controller. What is missing right now is the game state logic to know when to. So what we need is we actually need an event action, an event config data for this new type of thing that we're doing. So what we'll do, we have all these moves. Let's create some regions here. So these are move events. And then these are wall run events. Okay, adding a little note to myself that I really need to refactor how terrible that is. That I've created a 4x4 2D array to only use 4 nodes out of it to be able to look up start lane and end lane. It's a really kind of a terrible idea, but it was one of the fastest things that came to mind when I was implementing it. All right, now we'll create a new, well, I don't know about a new region entirely, but let's just create a new event config data for damage. Let's do separate. I know we're gonna want things to look different depending on whether it is a low obstacle damage versus high obstacle damage versus enemy damage versus pitfall damage. And what else, other kind of damage might there be? Hit you in the legs, hit you not in the legs, get hit by an enemy bullet, fall into a pit. I think that's it. I actually think that's it. And then that should be good, I think. Okay. So the first one that we'll do is a low obstacle damage because we want to see what happens if your legs get clipped because you didn't jump in time. Okay, so if the player state is we're both not already damaged and we are not invincible, and yeah, because I could also see adding some kind of mechanic that grants invincibility to the player. That seems like a pretty common kind of thing to do for any platformer, really. Let's do something fun here. Don't worry, you'll all come back. Alright, so if those conditions pass, then what do? We come back and, well, actually, we want the opposite logic. So we want to know if we are already damaged or we're invincible, then just don't do nothing. We don't need to register another collision. We don't need to do anything on a collision if we are in an invalid state to receive collisions. So we'll do that. Okay, so that means if we're past here, we're valid. And then if we're valid, then we start executing the event actions, which would be, in this case, so here we would do some kind of detect type of obstacle. Based on that, do specific event actions, but for now we're not gonna worry about that. We are just gonna do one of them that I know I have examples set up for. So we'll get the player controller data. I probably want to change. I'm gonna at the very least, let's change our local variable name. No, that might ruin what I have serialized. Let's just leave it. That's fine. Okay, let's get the low obstacle damage, and then we'll hook this up and see if it works, and then if it does work, we'll move on to other types of obstacles. So, let's see, we'll set up a config data, and we'll get the event data. We'll see if we can anyway. Wait, what am I doing? I'm good. This is what I want. Let's just get that, and then we'll do some null checking on it. And really, I just want to know that something has happened that's bad. Notify obstacle collision. Couldn't find event data. And that's all I want to know. Okay, so we have the low obstacle data. We've null checked it. If that goes wrong, then we error, and then we just return out of here. And then after... Yeah. Alright. Execute the event actions. So we'll do execute event actions, event data, which is our event data for the low obstacle damage. You see that? Okay. So what we're going to do again is expand the functionality of execute event actions.
I can remember taking walks by the lake with her by my side. I was maybe 11 or 12 at the time.
And, you know, while a lot of this prototype code has been kind of one-off-ish, I think this general pattern of abstracting configuration data of a generic event and then having a singular event processor is still fairly sound. It's probably the most architecturally sound thing that's happening right now. Mostly just because I don't, even though this is not super permanent code, I don't want to be throwing a bunch of duplicate logic everywhere with 15 if conditionals to know what one line tweak on the variation of that scenario needs to happen. Just create generic data that gets processed to handle the scenarios that you need. So in my case, I know that I have a player motion path spline, a eventually camera path spline. I just added speed modifier, and then I've got 2 more properties for the duration of the tweaks. So that's what I know that all of the events are going to process. So for every new type of event, as you can see, there's plenty of events. I've got, like 15, 20 events here. To expand and add those behaviors, I am just really adding 1 line of code for each new unique event, and then coming over to my sorry, wait for that to compile. But really, I'm just coming over. If you look at these are all those properties that I just looked at in that class. So for each event, all I'm doing is coming over here. I'm defining. Let's pick a more relevant here. So I'm defining a motion path spline and the duration that spline traversal should take, and now adding a speed modifier, and then whatever new features need to get added and for processing. Let's say we add what else could we add? Let's say we add camera shake, and we want to do, for damage, we want to do a camera shake. This is probably where that tuning variable, how much camera shake, what direction camera shake, all that would be added to this data structure. What else? Let's say we want to do bullet time. We want to do slow-mo, Trinity in the Matrix kind of stuff. This is where that time scale modifier could potentially go, and very likely will go, because I do want to play around with that. I don't know how relevant it'll be to the gameplay overall, but I could see there being some opportunities to do some cool bullet time slow-mo stuff. But yeah, kind of getting back to the kind of code architecture philosophies, that's really what the pattern that I have going here, that I do think is something that will stick around. Maybe not in this exact form, but it'll probably stick around in some form, maybe cleaned up. Maybe abstracted into, you could abstract this into a scriptable object if you wanted it to be dynamically loaded at runtime. It could be abstracted into a text file if you wanted to do it the old school way. There's a lot of applications for why to do it in this way for this particular design pattern. All right, enough computer science lecturing and more implementing of things.
Whatever, just get the money right.
So what we're going to do now is, where did I leave off? Is I'm adding... Oh, right. I am adding... that's why I went back to Unity. What I was actually needing to do is hook up the damage... Oh, maybe I did this on Friday. It was Whiskey Friday, so it's possible I forgot where I left off on this. So let's take a look at and refresh ourselves on what the state of things is in terms of setting up the animation controller for damage. So it looks like I do have a new parameter that I've labeled damage. And I do have a tree from any state to be able to queue. This condition should probably be damage. And then we do one of these. Bah! See that? Let's expand that. Oh, maybe that's as far as I can go. Okay. But yes, so we have this. Imagine we're running forward and we tripped. We got clipped in the legs by some obstacle we failed to jump over. And then from there, we make this transition. It looks like we're gonna want the speed. We're gonna want the speed to almost come to 0. It kind of looks like. Maybe 1, but this looks like we're coming to 0 for the most part. And then if you want to see what that animation is that we're blending, it's this, the traditional Kung Fu Kip Up, and hopefully it'll look pretty smooth in action like that. And then from there, we'll get back up and start walking and go into a jog and back into a run. Which this whole sequence will probably get reworked at some point. But not concerned about that. What we're concerned about is triggering this damage animation behavior. So let's trigger the damage first. Trigger the animation in the behavior that knows this is a damage event. And honestly, I think I may need to move the animation triggers into the event config data. If not now, then at some point. For right now, I'm going to leave them where they are. And then we'll refactor that as needed once we see the error of our ways. Okay, so we know that we have the event action. We're good, we're ready to go, and we're just executing them. So here we probably want to tell the animator, hey, let's set a trigger that we have called damage. All right, so we trigger the damage, and then we do whatever the motion path may be. But for now, let's just leave that null and see if we can trigger the damage animation controller state machine and see how that looks. I think we are good to test. Something's going, and then let's try jumping. Nice. So we successfully jumped over that and didn't trigger damage. Let's let this one hit us. Oh, nice. That's not too terrible. Can't take it no more. I'm going crazy. Ugh. Is this a game mouth sound. Mouth sound effects. Okay, so let's say, boom. It's not too bad. Now, if you imagine that we slowed down everything, that would look, okay, so let's slide into it. Nice. That is not too bad. Slide into it. Oh, I'm stupid. Okay, cool. Sorry. Short brain fart there. And okay, so we have a flag that lets me know that we are damaged. So what I'm trying to figure out is we need some kind of timing. If we're gonna adjust the speed, we need to know when to start transitioning the speed back to a non-modified speed. So let's figure that out. So what we want to do here is, this is a slightly trickier topic than what we've been dealing with so far. This one actually requires some interpretation of game state and player state, which is not something a lot of other features have been doing up until now. Okay, so we have this. We have the tween for the motion path. So I think on this same timing, let's tween the level traversal speed. So what we're tweening is the. Nope, that's not it. What is this type? Oh, it's compiling. 1 second. There we go. The level generator is the type that I need. I think I have a reference to it, and if I don't, then I'm going to add one. I don't think I do, so let's add one. Hey, Terax, welcome. I don't think I've seen you around before in the chat. If I have, correct me, but welcome. And what we're going to do here is, now that we have a reference to the, let's start that compiling. Now that we have a reference to the level generator, what we can do is we can tell it that we want the speed. Hello! Yay! Thanks for following. High five. Much appreciated. Excited to see what your stream avatar turns into. Thank you for the follow. Glad to have you. If you have any questions, just shout them out in the chat. The more chat, the happier I am, because I don't have to make up things to talk about. So we have this level generator, and why can't I... What would you possibly name the property to control the speed other than speed? Said the developer to the plugin. Speed. No? Okay then. Fine. Be that way. Let's see what is in your guts. Generate segments ahead. Then where is this speed? No? Wait, what? Do I just have the wrong data type here? Level generator. And then... Oh, okay. That is my fault. I have the wrong class. What I actually want is the runner class. My bad. The level generator controls generating the level, turns out. And what I need is not that. I need the thing that traverses the level, which is the runner type of this plugin. I'm not 100% sure I'm gonna continue using this plugin all the way past prototyping, but for now it is helping me make faster progress than I may have otherwise. So let's link up the correct class. A little bit annoying that it's just called runner. It's a little non-descriptive for like what are you? Are you a utility class? Are you a data type? Are you mono behavior? What are you? But that's me. I'm a little excessive on the functional naming philosophy. Sometimes maybe to a fault, but it does creates self-documenting code, which is something I'm pretty passionate about. Mostly because it shuts down a lot of my own personal former bad habits with naming things. If you name something what it does, 95% of the time it will be self-documenting and legible when you come back to it 8 months in the future and need to debug something. There it is. Okay, so now that we have the correct component linked, we can do speed. We can set the follow speed. And follow speed, I believe, should be a float. It is a float. Perfect. So we want to set the follow speed to X, and then the end value should be level data. Let's just take the average run speed. Average run speed times, and I should not put this just blindly within. Let's set this to mod speed final or end value, and then see, here we go. This is more that functional variable naming where you don't have to really sit and think about the variable name. Also, when you just know that you're gonna name something what it does. I just know that this is a modded speed and it's the end value for this tween, so mod speed end value, easy. So that becomes the level data dot run speed average. We're just hard coding this for now because we don't have the modular or the shifting velocity of run speed set up yet. Hey, Terax, I see your little doggo avatar down there. Thanks for the follow. Glad to have you down there and represented. Have fun. Let me drop some celebratory stream currencies down there. Okay, so we'll set that to the event. Where Where's my event data? What did I call it? It is called... I probably just called it event data. Yep, there it is. Event config data. Dot speed modifier. Whatever the speed modifier is. And let's only do this if the event config speed modifier is not equal to 1. Because 1 just means you're not modifying, so you don't need a tween. You don't need a tween worth a damn if you are not modifying. So let's do that. Okay, so we've wrapped that. We only do this tween if we have a speed modifier that is not 1. And then... Ooh, this is a good song. Let's turn this one up slightly. I like this song more than I like this game. Which is mostly to say that this song is just really good. And then we have runner follow speed, and then instead of doing this calculation in line, we'll send in the variable, and then we'll use the same tween duration as the player motion tween. Then we will continue on to complete. That's what we need to figure out is when do we remove our speed modifier and how do we get back from there? Because once, completing the tween into the new state doesn't mean that we're done with whatever that's, in the case of a wall run, you are in that wall run state for as long as the wall lasts. So we need something else to determine when the player's speed gets reset to normal. So, but for now, let's just do something on callback here. We'll just stub that out to when I do know if there's anything that needs to happen after a speed mod has happened, we'll put it there. So that's good. That's set up. Yeah. And then let's do a quick test of this just to see if this logic is working. Our baby Yoda down there is sleeping very peacefully. That costume looks pretty hilarious when she's lying down and sleeping. Okay, so that's compiled. We come back over here. Let's set the... Oh, first off... No, actually we're good. Okay, low obstacle damage. Sorry, let's put this in a spot where you can see it. Okay, low obstacle damage. Let's set the speed modifier to 0. We're basically going to tween to 0 from the origin. And then, you know what we're going to do? We're going to immediately tween back. Yeah? Maybe? Well, all I know is that we are going to need some kind of reset player state at some point, more than likely. So we'll just call it that for now. And this may not be what we inevitably want to do for real, but let's just call it this for now. So we reset the player state, and for now, all I want to do is just take the speed back to the norm. And that's it. So with this can be is on complete. Let's see, can we just do this? Reset player state. Seems fine. And then we're gonna take the runner follow speed and go from it to the end value of level data, run speed average, and then the tween duration can let's just hard code it to 1 for now, and then on complete we actually don't need to do anything for the time being. Let's just have this be a real simple get back up to speed time, and then we can also reset the player state.isDamaged to false so that we can receive damage once again. Okay, that'll be the most simple version of getting damaged and being reset back to norm. Alright, boom, look at that slowdown. Okay, it's not terrible. Let's jump over that just to prove that we can avoid obstacles. And then the next one we will let it hit us. Bam! Okay. Okay, so I think that's like a half second, maybe 1 second too short of a tween. So let's go in here and let's just amp that up just to see what it's gonna look like. So the low obstacle damage, let's just say that we take 2 seconds to tween that and see what that looks like. One more time? Say that one more time. Okay, that's not too bad. The only thing that's janky about that is the walk, jog, run, getting back up to speed. But that's janky to begin with. I don't. But that is not awful. And then what happens if I roll into... Hey, nice! That did not look terrible. Oh, I think I can juke it! I'm wrong. Okay, and then let's go to this side lane. And then let's slide into this one. Slide! Oh. Okay. I'm gonna say that is not a bad first implementation. And we can just work on finessing the reset player state sequence of getting back up to speed. Let's see it one more time, just for the sake of stupidity. That's not bad. And then if we just make that tween back up to speed, tunable, we can make that look pretty decent, I think. Oh no, why did you go to 20? Crap. Okay, get hit, go to 0, exit, stay at 0. Perfect. Slide under, get plus 20. Slide under, up to 40. And then get hit, and we should come out the other side at 20. Perfect. And then let's get hit again and go down to 0. 0. Great. Now, let's see if we can get to top speed. 20. 40. 60. Now we're going sprint speed. 80. 100. Nice. And as you can see, all of a sudden I do not have a ton of time in between anymore before I have to hit the next dodge. And it really commits me for quite some time. So if I mistime it, going faster hurts quite a bit. If you imagine enemies coming and shooting and throwing things your way on top of all of these obstacles. Okay, so let's trip, go down to 80. And then trip again, go down to 60. And you can see that the attack power changes my attack. Ow. Okay, 40. See, different attack. 60, back up to speed. 40, back down to regular running speed. 20. 0. And then let's watch for our magic lost condition. Oh, you lose. You died. You done dead. Perfect. You died, you done dead again. All right. We did it.